Students, good afternoon. Hello, good afternoon, dear students.
Good afternoon, ma'am.
Very good afternoon. Good. Okay, which slide is visible to you?
Yes, ma'am.
Which slide is
Yes,
visible?
ma'am.
Level shift stage in Opamp.
Very good. Very good. Okay, beginning of the class, just 1:30. It has turned 1:30. Now only 21 students are here, right? And in between, sometimes I forget, sometimes I take, and only at the beginning it is very important. Of course, at the end also I take, in between 4 or 5 times I am taking, right? Ask all your friends to join on time. Now let us move forward to our regular class, regular discussions, right? Okay, a level shifting stage we are discussing. And what is this level shifting stage? We have seen in uh, the block diagram of a typical op-amp. The block diagram of typical op-amp consists of various stages, and in the previous class we have seen all these stages, right? And I have mentioned that we will see this level shifting stage in today's class, right? And now input stage we know, dual input balanced output. Intermediate stage we know, dual input unbalanced output. Amplifier, differential amplifier. Output stage, complementary symmetry, push pull amplifier. Okay, and here in the level shifting stage, what type of circuits we use, all that I have just mentioned, right? So emitter follower circuit uh, using some constant current source is used as a level shifting stage. So what is this level shifting stage? Why this level shifting stage is required? We have seen in the previous classes. Once I will recap and then we move forward to the level shifting circuits. Okay, so before that, any other section students are here, you please leave this class and join in your corresponding class. Otherwise you will be losing your attendance in your respective class, right? And one more thing, you please right, you please remember that if you have any, if you create any disturbance, you will be removed from the group. Be careful. And one more thing, you have answered your quiz very well, and some of you, I think very few of you got 10 out of 10. Compared to section C, section A people got less number of people got 10 out of 10, right? Section C, many students got 10 out of 10. This shows that, I don't know, both of you have some equally fresh hours only, right? You please pay more attention, and a very less number of people got 8 or 9. Of course, many people got 8 or 9, and so many got 7 and 6. But there are some students with 0 marks also. Only one student got 0 mark. Thank God they have learned to submit Google form. Only that they have done, right? Except the subject technology, that is submission of Google form he has done. For that I'm happy. But still, without the content, that means if you do not know the concepts, it is of no use, right? So you are struggling hard. We are also working hard for the benefit of our students, right? A college is providing a lot of facilities like internet and all other facilities, and all the teachers are committed to teach you well. Therefore you please make use of all the facilities that are given and try to learn the subject. So today's situation is different. Tomorrow everything gets set right. Okay, so that time if you are competitive enough, then only you will be able to grab some of the jobs. Otherwise, no sir, in interview if they ask you one question, what is the output stage at typical op amp, it is amplifier or complementary push pull amplifier, like that if they ask, sir that time our lecturers taught us very well, but due to COVID we were not able to focus much, so you please excuse. You cannot ask such excuses. all these situations are not only for you, all these situations are common to all the people on earth, I can say, right? So therefore, in spite of these disturbances, everybody is struggling hard to move forward. So I request all section A students also to put more effort, and I think if you want to prove that you are good in unit 1, I'll give you one more quiz, right? If you want to prove. Otherwise, what I think is, uh, some of you, right? I'll tell you those names and all later. Names means I'll just mail that to you, or I will show in our chat box. Some of you got very less mark. Therefore, uh, shall I conduct quiz one more time for you? Of course, for the other section also, I didn't ask them. Shall I give one more quiz from same unit? See, in order to give quiz, I have to prepare Google Forms sheet. I have to search again new questions and their new options. And I have to work very hard. But still I am ready to do that because you people should gain some knowledge. Okay. So only for you, what will you do? You will be just reading the question and marking the corresponding option, multiple choice questions only. So like that you are doing, it doesn't take much time for you. It is, I think, less than 10 minutes, 5 or 6 minutes you will be able to complete. But for that I have to work at least 2 or 3 hours. I have to search frame questions, I have to prepare them, prepare their options, and everything I have to write in forms, and I must do all that. But for the benefit of my students, I want to do. If you want, I will conduct one more quiz. Otherwise, if you say no, not necessary, ma'am, we are good students, we are following well, means I will proceed further. No problem for me. So you tell me whether I can conduct one more quiz or not. Yes, you are good students. So what is that? Silence is acceptance, I can take. But I know your silence is different, right? So you do not want to take up many tests. Therefore, I don't want to conduct. Okay, because they are maintaining silence. Okay. Now let us see what is that? The level shifting stage, right? So what is the heading for this slide? Are you connected? Are you in the call, or suddenly all students have disappeared?
Intermediate stage,
Yes, ma'am, we are there.
Because for quiz question I didn't get any response. Okay, silence I thought. For this question also, by observing your response, I thought you are not connected. Good. Intermediate stage, right? So the main requirement for intermediate stage is two requirements. That is, the main requirements for intermediate stage, two requirements. One is voltage gain, very high voltage gain it should provide, and a direct coupling without using coupling capacitors. Okay. Therefore, because the coupling capacitors are not used, what happens means, because the coupling capacitors are not used, the what is that, DC signal propagates through the amplifier chain, and finally there will be some significant amount of DC component at the output of the amplifier. So at the output of the amplifier we need only AC but not DC. Therefore what we do is we try to take care of that problem. And not only that, that presence of that DC voltage, it also distorts our output. That means input is like this, and output voltage will be like this. That means the shape of the waveform should be same. Otherwise we say there will be some distortion. So we don't want that distortion. But because of the presence of DC level translated, what happens, there will be some distortion. That distortion, what it will do, it is clipping off some of the output waveform. Therefore that we want to manage, or that we want to control. And not only that, this DC voltage that is present at the output of the amplifier, it limits the maximum output voltage swing, right? It limits the maximum output voltage swing. So all that I have shown, right? So that DC level, whatever is shifted, that we want to bring it back to ground level. So to do that, we use these level shifting stages. So this is the output of the amplifier with the 0 DC level. This is the output of the amplifier with the 0 DC level. And when there is DC level added, so this waveform shifts upward, right? So the same shift you can see here. So this much DC is added. Therefore, this waveform shifted upward. So, but the maximum V plus VSAT and minus VSAT are fixed for the transistor. Therefore, it cannot allow more than certain voltage, and therefore what happens means it is allowing maximum value, but the output is beyond that. Because of this shift, that waveform will be clipped off. So this is the clipped waveform, and therefore the input should be sinusoidal wave, and exact shape should appear at the output like this. But because of this clipping, because of the presence of DC voltage, because the waveform is clipped off, and therefore the shape of the waveform is different from the expected waveform shape. Therefore there is some distortion. So we don't want any distortion here. So that distortion we want to remove by shifting this DC level back to ground level, right? So it has shifted up, that we want to bring it back. That means if this is the figure, we'll just pull down. That means what we do, what we are going to do is we are going to design some circuits using emitter follower or what is that, common collector amplifier, emitter follower. And with that circuit, why we have chosen emitter follower means emitter follower gain is same. That means gain is unity. Whatever input you give, the same output will be available at the output. So that means no further amplification or no further reduction of the signal takes place. So there will not be any amplification. So at the output of your intermediate stage, if you connect level shifting stage, what will happen? You just see. This is the output of the intermediate stage. Here, if you connect level shifting stage, there will not be any amplification. Only if there is any DC level shift, that will be shifted down, and the effect of this DC waveform or DC voltage will be eliminated, and that will be given to the next stage. So that is what we are planning to do here, right? So this DC level we'd like to remove. So I think up to this we have discussed in the previous classes, previous class, that is DC level shifting circuits. One such circuit is circuit 1, that is simplest level shifting network, that is with emitter follower. So emitter follower, as the name shows, the output follows the input. That's why emitter follower we say. This is the common collector amplifier. A common collector amplifier means collector is grounded, and a collector is common to both input and output. Input side base terminal, output side emitter terminal, right? So at the emitter we take output. So this output is what? It follows the input. That's why emitter follower we say. So voltage gain is unity. So that means for your whatever gain you are getting at the intermediate stage, the same gain will be maintained. Only thing that unwanted DC will be shifted downward. So for that we can use this emitter follower circuit. This emitter follower circuit is shown here, right? Now if you write KVL at this input minus Vin plus VBE plus V naught equal to 0, right? Minus Vin plus VBE minus minus Vin here. From here we start minus Vin plus VBE plus V naught equal to 0, right? So if you rearrange, you will get V naught is equal to Vin minus VBE. V naught is nothing but the voltage drop across this resistor only. So this is the loop, right? minus V in plus VBE. Here that minus is for VBE. VBE plus terminal here, minus terminal here. And this is resistor current entering terminal. So plus V naught. Okay. So V naught is equal to V in minus VBE. Right. That means at the input of this amplifier, this circuit, if you give V in approximately, let us assume, just for clarity's sake, I am giving what is that numerical values. V in 10 volts. And what is the typical value of VBE? What is the typical value of VBE?
0.7 volts.
Very good, 0.7 volts. So V in is 10 volts, minus VB is 0.7. So what is V naught? 10 minus 0.7.
0.3, ma'am.
9.3. 9.3, right? So that means if V in is 10 volts, V naught is 9.3. We are able to reduce the effect of V naught. Actually, our aim is what? This V naught should be 0. DC V naught, that is this V naught at the output DC level should be 0. But what we have done with this simplest arrangement, not 0, but to some extent, just to some extent we have reduced. But our aim is what? To pull this DC level to 0. That means we are trying to make this V naught 0, V naught 0 without affecting AC signal. We are trying to make this V naught 0. But what we have done, earlier V naught was 10 volts, right? V naught was, earlier V naught was, V in is 10 volts, or earlier some value is there. Now you are able to shift this voltage to 9.3. So only thing is you are not able to do anything with this simple arrangement. If there is some voltage, you are able to shift this DC level little bit only, right? So you are able to shift this level very little bit only. So as it is, this emitter follower circuit is not that much useful. So what we do is we are trying to modify this circuit. Why we stick on to emitter follower only? Emitter follower only, gain is unity. So here what all gain that is required is obtained at intermediate stage. Therefore here we need not increase or we need not bother about gain. We should bother about level shifting only. So gain should be same. So in such a way, that means AC voltage gain or differential gain should be same, but we are trying to eliminate this DC component, DC output voltage. So DC output voltage we are able to reduce only to some extent. Okay. So now what we do is we modify this circuit. So that means just we add one more resistor here in series with this resistor R. Let me show you, that is the level shifting circuit 2. The level shifting circuit 2, right? So please note down this first circuit. I hope you have noted down. During my explanation you are noting down, I hope. And now you please note down this level shifting circuit 2, right? Now up to this circuit is same as we have seen in the previous slide, previous case. Only thing is this one more resistor R is replaced with resistors R1 and R2. And voltage drop across R2 is V naught. So this voltage drop across R2 should be high or low. Our aim is to set V naught. V naught. We want to make this DC voltage V naught 0. That is what our aim, right? So we are trying, that's why previous circuit we are not able to make it 0, but what we are able to do is we can make it actual value minus 0.7 volts only. That means we were able to reduce to some extent only. So our aim is to make this V naught as small as possible. So for that one more resistor is added here. Now if you add this, let us write KVL for this loop. For this loop, minus V in plus VBE plus I into R1 I into R1 plus R2. This is the voltage drop, right? These two resistors are in series. So I into R1 plus R2 equal to 0. So this is KVL to base emitter loop. KVL to base emitter loop. Have you written this equation? Have you written this equation?
No, ma'am.
Right. While I am talking, you please write, right? V in minus, first step I have written minus V in. So here with respect to ground we start, right? So this is minus, this is plus, and we start from here and we end with this ground. That's why I write from here minus V in plus VBE, and this is plus, right? Plus I into R1 plus R2 equal to 0. Otherwise, you rearrange this equation, that is V in minus VBE minus I into R1 plus R2 equal to 0. You just rearrange this equation and you express what is I. You rearrange this equation and express what is I. What is I? One of you tell me from this above equation, what is I?
V
I,
minus VB.
by?
Minus VBE by R1 plus R2.
Very good. That is what I have written here. I is equal to V in minus VBE divided by R1 plus R2, right? So this is I. Now voltage drop across R2 is V0. Voltage drop across R2 is V0. So V0 is equal to I into R2. That is what I have written here. V0 is equal to I into R2. What is I? We got expression for I. You substitute that I value here in this equation, you will get what is V0. V0 is equal to V in minus VBE into R2 by R1 plus R2. Previous case, without this resistor, we got V0 is equal to V in minus VBE. Now what we have done? We have added one more resistor like this. With this arrangement, output can be controlled by a factor R2 by R1 plus R2. With this type of arrangement, output can be controlled by a factor R2 by R1 plus R2. That means V0 can be made 0. V0 can be made 0 by proper selection of R1 and R2. By proper selection of R1 and R2, we can make V0 0. We can make V0 0, right? So our aim is to make V0 0. What is this V0? DC voltage, DC output voltage, right? Because of that, there are some disadvantages. So we want to make this 0, right? So is this circuit clear to you? Is this circuit clear?
Yes.
Yes. Okay.
Yes, ma'am.
With this arrangement, we have some disadvantages. Let us see those disadvantages. Okay. And by proper selection of resistors R1 and R2, voltage level at V0 can be controlled. That is what we have concluded. Okay. So that means the main drawback of the circuit is the signal voltage also. Signal voltage means what? Our AC voltage, the signal that is required for us, right? So I told you this is the AC signal and it will be the amplified signal. That's all. But all other things are not required for us. So what happens means when we are controlling this V0, when we are trying to control this V0 by a factor R2 by R1 plus R2, what is happening means our AC signal also is getting attenuated. AC signal is also getting attenuated. That means AC signal is also getting reduced. So that is one disadvantage. So the disadvantage with this circuit is AC signal, AC gain starts decreasing. Actually, with intermediate stage, we are trying to achieve higher gain, but that achieved gain is getting reduced with this type of arrangement. And not only that, another disadvantage we have, that is output impedance is becoming high, right? Actually, if you see what is that for any amplifier, we calculate four parameters: current gain, right? Then voltage gain, then output resistance and input resistance, right? So if it is a voltage amplifier, we focus more on this, and our differential amplifier current gain is undefined, voltage gain we have seen, and input resistance always very high, output resistance always very low, right? But here what is happening, our voltage gain is decreasing, it should be high, but it is decreasing with this arrangement, and output resistance is increasing, actually it should be less, but because of this arrangement output is increasing. That means this circuit is providing, it is controlling, that DC voltage, right? But it is providing two disadvantages. So therefore, how to eliminate that is another circuit. So this is another circuit. With which we can eliminate that problem of signal attenuation and also high input impedance. I mean high output impedance, increased output resistance. So this is level shifting circuit 3. If you observe, all the circuits are developed from emitter follower only. This is the emitter follower, right? Initially this is what we have considered. After that, below R1 we have collected R2. With only R1 we understood there is no much variation in the output, right? DC voltage earlier if it was 10, now it is becoming 9.3, no much variation. So as it is, that arrangement is not that much effective. So we have added one more resistor R2. With R2 we will be able to control to the maximum possible extent output voltage, but it is introducing two more problems. That is, it is affecting the gain and output resistance of the amplifier. So therefore we go for another circuit arrangement. So this is the level shifting circuit 3. This level shifting circuit 3, you observe, right? This level shifting circuit 3, this is the constant current bias circuit. This circuit is also named as constant current bias circuit. So this constant current is provided from transistor Q2, right? So this constant current is provided from transistor Q2. Now these two diodes are for some thermal stability, like that we have added here, right? So this is the circuit arrangement with the constant current bias. For this circuit, let us see what is V0, right? V0 is equal to Vin minus VBE minus I1 R1. So this is voltage drop across this ground with respect to ground from here. So therefore this is V0. So you can write V0 is equal to, earlier here in this place we got resistor R2. Now in addition to this R2 we have some constant current circuit here, constant current circuit. Okay, so now what happens means you just observe the circuit.
Hello, ma'am.
Hello.
Ma'am, sorry for the interruption, ma'am. Some sort of disturbance is coming, ma'am.
Okay, I'll stop.
Okay, ma'am.
Right. Okay. Now you just observe Now I think you don't have that disturbance, no? Still you are getting
Yes, ma'am. No disturbance, ma'am.
right, right. Here now I have a small table fan here because while taking class, full sweating we are getting. So for some time I'm switching on, right? So whenever if you don't hear any, I mean if you hear any noise, you please let me know. Most of the time I'm putting off, right? Only under worst situation I just switch on for some time, right? Sometimes I will forget also to switch off. If at all, if you remember, you I mean if you feel inconvenient, you please inform me immediately. Just for a few seconds only I will switch on, right? One more point, let me take your attendance. There are 54 attendees. At the beginning only I have taken only 21 or 22 like that, right? So I'm not going through your chat, ma, because I'm fully on PowerPoint screen only, right? So all those controls only whenever it is required I see. So if you have something to convey directly, no problem, you can unmute and you can convey. I appreciate you all because you are not at all creating any disturbance. You people are good. If at all if it is required, you just unmute and talk to me, right? So if at all if you are creating lot of noise, then I can mute all the students. That is not necessary. Till now I have not muted anyone, right? So I'm giving it free, I'm leaving it free, but still you people are good. You are maintaining your decency. For that I'm happy, right? So now let us see, this is another circuit, okay? So let me repeat here. This is any circuit we are developing, modifying with the emitter follower circuit only. This is the basic emitter follower circuit we have taken, and after that, with this simple direct emitter follower circuit, we got V in is equal to V naught is equal to V in minus VBE. With that, we didn't get much effect. Therefore, we have added one more resistor at the bottom. So now what happened? That resistor R2 and R1, and that with some factor R2 by R1 plus R2, the output we are able to control. That circuit is good, but there is a problem that it is affecting or it is attenuating the required signal, and it is unnecessarily increasing the output resistance. So when you design an amplifier, you should design in such a way to have very high input resistance and low output resistance. Why low output resistance? When it is connected to next circuit, there should not be any loading effect. Why high input resistance? You should be able to get connected properly with the input source, right? So that's why always when we design amplifiers, we design with very high input resistance and low output resistance. But this previous circuit arrangement is providing a high output resistance, one disadvantage. Other disadvantage is it is reducing our AC signal gain also, right? So the required signal also we are losing. So therefore, that circuit, same circuit is modified like this, right? So in place of R2, a constant current bias circuit is connected. So this transistor Q2 provides constant current circuit, constant current, right? Diodes D1 and D2, they are connected here for some thermal stability of the circuit. Okay. Now for this circuit, let us write KVL. That is voltage drop here connected to ground. Okay. That means this V in other end is connected to ground now. So therefore, let us take DC source it is. Other side is grounded. That means this ground and this ground. So when we write KVL, what happens means V naught is equal to V in minus VBE minus I1 R1. This is R1, this is I1, right? So that means, right, that means not only V in minus VBE, another parameter minus I1 R1 also is coming into picture. Therefore, what happens means at the intermediate stage, right? From here, from intermediate stage, you are getting some voltage, right? That voltage here it is output, and that is given as input to your level shifting circuit, right? Now, at the level shifter, you should get output here. So, V in is V naught, otherwise V naught is V in. Now, with our, we want to increase this V naught. V naught is equal to V in actually, right? With the emitter follower circuit here. So, but what we are trying to do, we are modifying this emitter follower circuit so that V naught is less than V in. Like that, less than to some V in minus some greater value, then what happens? This level will be shifted down and V naught will become 0. So, that is our aim. Right? Circuit 3, for circuit 3, circuit 2 V in for circuit 1 V in minus VBE, right? So very small value only variation. Now minus another component, therefore V naught will become still smaller. So like that, compared to the previous cases, compared to the first case, first circuit, this third circuit will reduce V naught to a greater extent. Our aim is to make V naught 0, right? But not exactly 0, we are trying to pull it down, right? So by proper selection of R1 and by allowing I1 the required value, that means proper selection of R1 makes this V naught 0 with this arrangement, right? So with the previous arrangement also it is possible, but in previous arrangement gain is decreasing and output impedance is increasing, but here no such disadvantages. That is one advantage with this level shifting circuit. Now let us come to the next circuit. This is level shifting circuit 4. Level shifting circuit 4. This circuit also you just observe, same emitter follower circuit. The other part of the emitter follower, previously constant current source, now here current mirror circuit is connected here. Current mirror circuit means same current. If you see your face in mirror, you will get mirror image, right? Similarly, this is current mirror arrangement. Previous case it is diodes connected like that, and now this is the current mirror circuit. Now if you observe this fourth circuit, you just see current mirror action. I1 is equal to I. This is I1 and this is I, right? Both are same. All right. Okay. Now let us try to express what is this I1. I1 or I. For that what we do in general, our same equation, right? Otherwise you can write I1 or I is equal to, right, VE minus VBE, sorry, V in minus, where is that? Sorry, right. Okay. So I is equal to, let me write this KVL for you so that you will understand very easily, right? Plus, you just consider this loop. Right? You please consider this loop. What is this loop? Minus VGE plus, let me write this. Right. Okay. So let us write, what is this? Let us write V naught. Let us write V naught. What is this V naught? Let us consider this loop first. Previous case. This minus sign and this ground and this ground. So V naught is equal to V in minus VBE minus I1 R1. Right? V naught is equal to V in minus, are you writing? V in minus VBE minus I1 R0. V0 is equal to, right? So what is this I1 and I2 means? I1 or I2 you can express here, from here I you can express, right? So this loop from here, you take this loop, loop 1, minus VEE, right? Minus, again I wrote wrong this, wait, just a minute. Let us take this. Any loop you can take, no? Algebraic sum of voltages in a closed loop is equal to 0. Why we take all these means, for our convenience only we take, right? So this you write it as loop 1. Loop 1. Now you see here minus VEE, right? Otherwise, okay, from here only we should go. So when this is VEE, right? When this is VEE, the other end will be, this is minus and other end is plus, right? That is connected to ground. That means from here we take, now because the other end is grounded and here the other end we have to take. So from ground we take. Therefore what we get? Plus VEE. So plus VEE. Are you able to follow what I am doing? Plus VEE minus, here you see VBE, base emitter voltage, right? So here minus, opposite direction we are giving. So minus VBE minus IR2, because I is in this direction, we are going in the opposite direction, minus IR2 equal to 0, minus IR2 equal to 0, right? I repeat how we have taken this loop, right? So here are you able to catch why I have written plus VE, right? If it is what is that, plus V in, corresponding other terminal we are taking, because at ground only we are starting, right? Connecting, we are stopping. Therefore minus V in plus VBE, like that we are writing, no? Similar way here also. Now it is minus VE, therefore the other terminal is connected to ground. So when we see from ground, this side ground, so this is the closed loop, this is the closed loop. Therefore when you start from the source, first terminal what you see you have to write, so that is plus VE, and here this is plus and this is minus, therefore minus VBE, and this is the current entering terminal to the resistor and this is the leaving terminal, therefore plus VE minus VBE minus IRA equal to 0, plus VEE minus VBE minus IR2 equal to 0. Is this equation clear to you or not? Is this equation clear?
Yes, ma'am.
Yes, okay. So therefore here you write what is the expression for IE. I is equal to the expression what I have shown here. I is equal to this VEE by R2. That means here also in this circuit, V0 is equal to V in minus VBE minus some other minus parameter. So what happens from V in, if you have so many minus parameters, that means if it is maximum V in value, for example V in equal to 10 and VB is 0.7, right, 0.7 minus some other value, so maybe 2 or 3 or 4 something, then what will happen? V0 comes down. So like that, if you select properly in such a way, if you get this product more or less equal to somewhere around 9 or 9.3 like that, then it will become 0. So by proper selection of resistor R, output can be brought to 0 level. Followed? Followed? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes. Our aim is to make V naught 0, and with this arrangement it is possible to make V naught 0. We are coming to the end of the class. Right, I want to take one more circuit also. Shall I move forward? Right?
Yes, ma'am.
Yes.
Right. The next circuit is, till now what we have done, we have made some, what is that? V naught is equal to Vn minus VBE minus some other parameter, right? So in this circuit, we have made some other arrangement so that VBE becomes multiplied. VBE multiplier circuit it is. That means V naught is equal to Vn minus VBE actually. Vn minus VBE. So in the same example, Vn is 10, VBE is 0.7, so output is equal to 9.3, right? Now VBE you cannot do anything by manufacturing process. For the silicon transistor, if with variation in temperature, it will vary slightly, that's all, 0.6 or 0.7, right? So you cannot increase this VBE by any means. So therefore, this direct circuit will not provide much effect. So what we do is, if this VBE is made multiplied with some other factor, for example, if this is made uh, multiplied with a factor 4, then what will happen? Output is equal to 10 minus 0.7 into 4, 2.8. So what will be the output? What will be the output? 10 minus 2.8. Are you searching for calculator?
7.2.
7 point?
7.2, ma'am.
7.2. Right? Previous case it was 9.3. Now it is 7.2. If this parameter, if instead of 4, if it is 10, what will happen? 10 into 0.7, it will be 7, right? So therefore 10 minus 7 will be equal to 3. So that means with some other circuit arrangement, if we have some VBE multiplied with some multiplying factor, then also it is possible for us to make V naught 0 or V naught smaller. Are you able to understand the concept? Right? So that's why this VBE multiplier circuit is used. Now let us see between points A and B. Between points A and B, actually this is our actual emitter follower, and for that one more resistor added, right? Now one more resistor is added, and between points A and B, one transistor is connected like this, right? So base here, collector here, and emitter here. So with this type of circuit arrangement, what we do is we will get some multiplication factor with VBE, right? So let us see that circuit, that equation, right? Now let us assume that current I is flowing through resistor R1 and R2, assuming that there is a very negligible current flowing through this, because I is entering here. At this point it has to get divided into two directions, but let us assume that it is very small, negligible. So let us assume I is flowing through R1 and R2, right? So from A to B is equal to V between points A and B is equal to I into R1 plus R2. So I have written here V between points A and B is equal to V between points A and B is equal to I into R1 plus R2, right? Now apply KVL to base emitter loop of transistor Q2. Let us see transistor Q2 base emitter loop, right? So from this base emitter loop, what are the terms we have? R2 and VBE, right? R2 and VBE. Right? Now, what is this? I R2 is equal to VBE, right? This is I into R2. This is I. This is the voltage drop here. I R2 is equal to VBE. Then see, this is current entering terminal. So I think KVL I need not explain, but this is minus sign. So from if we start from here, we'll stop here. So minus IR2 plus VBE is equal to 0. So that means IR2 is equal to VBE, and then I is equal to VBE by R2. I is equal to VBE by R2. Right? So what is VAB? VAB is equal to I into R1 plus R2. R1 plus R2, okay. In place of I, you write VBE by R2. So finally, we get VAB is equal to VBE by R2 into R1 plus R2. Did you get this? VAB is equal to VBE by R2 into R1 plus R2. Did you get this expression?
Yes, ma'am.
Yes. Okay. Now let us see what is VAB. VAB is equal to, you take this R2 into the inside the brackets, then VAB is equal to VBE into 1 plus R2 by 1 plus R1 by R2. Right? So you express VAB, which is equal to VBE into 1 plus R1 by R2. Now our aim is to express what is V0, right? V0 is equal to Vin minus VBE minus VAB. Let me show you the circuit. V0 is equal to, I'm searching for my cursor always because it is the very short, right? So what is V0? V0 is equal to Vin minus VBE minus VAB, right? VAB, right? So now what is this? Otherwise what we write actually minus Vin plus VBE plus VAB plus V0 equal to 0, and finally what we write? V0 is equal to V0 is equal to Vin minus VBE minus VAB. So Vin as it is you substitute, you write VBE, you write as it is. VAB you got in terms of VBE, you write that VBE expression here. VBE expression here. You take VBE common, then VBE 1 plus 1, 2. So Vin minus VBE into 2 plus R1 by R2. That means by proper selection of resistors R1 and R2, V0 can be adjusted to 0. V0 can be adjusted to 0. If you make one resistor as a potentiometer, just by adjusting you can decrease the value of potentiometer, means directly you can vary. If it is a fixed resistor, you have to remove that resistor and you have to place another resistor. Instead of that, if you make one of these resistors as potentiometer, just by rotating, just how we increase volume, right? In your regulated power supply, how you increase voltage. Similar way, if you adjust that resistance, you can make this V0 0, right? So like this, these are so many circuits that are used for what is that? Level shifting circuit, level shifting in op-amps, right? So this is the circuit that is commonly used in our op-amp. Now let us see another circuit. This is NPN and PNP level shifting. PNP and NPN level shifting network. This is another network. With this also we will get R2 by R1 into VCC minus VBE. This is not that much required for you. So with this what I can say is we have almost completed our unit 1, and if possible I'll give you this problem later. Now let me tell you about your we are coming to the end of the class, so I want to give you some more concluding remarks for this unit 1, right? That is quiz 1 link already it was given to you, but anyhow, whenever I give quiz next time onwards, it will be available in my, of course, if at all, if it is immediately required in the class, I'll share in chat box. Otherwise, I'll ask you to visit my website. Then this is the link already you have answered, and in the beginning of the class itself I have mentioned your performance is average, not excellent. Okay, so we have to become better and better day by day. So but when I asked you whether you want to have one more quiz or not, you people kept quiet. From that I understand that you are not that much interested to answer the quiz. So just for fun sake only I plan to give actually. So therefore I am not going to give you any quiz, but assignments and mid examinations I cannot cancel like that. Okay, quiz is extra out of the way with some more effort we are doing, right? We have learned how to set a quiz in by using Google Forms, all that, and we are learning and we are giving, right? Now all the material, course material, quizzes and assignments I will be placing in my website. Okay, you please note this website, right? sites.google.com/view/my name, right? After that put one more slash and write what is that, right, LICA. So there are other courses also, so all the courses that I handle will be there. So you visit this website. I think if it is like that, you will see next to that you can see my name and all, right? Here if you click, you will get courses, students, publications, all that. So and for you, my publications and my students are not required for you. Therefore you click on courses, you will get first sem course and second sem courses. First sem course, your LICA will be there. You click on that LICA, you will get your material. Of course I have not uploaded, right? I have given you the path. Just at the end of the class only I want to upload our videos. I have to verify our videos. In between mute your mic, all such things will be there. No, I have to eliminate that. That too class means I have gone slowly, and 1 hour we have taken, but uploading such 1 hour classes in YouTube and website is not that much effective, but I'll see what to do. If at all, if I have time, I edit and upload, otherwise I directly upload. So there you can see my lecture notes, slides and assignments, all that. So why I am telling you all this at this moment is, by today evening I want to keep your assignment 1 questions, right? So assignment 1 questions I want to keep by today, or at least by tomorrow I will keep, right? So today as early as possible I want to keep. So today after this class itself I thought of placing your questions, all the question bank, everything is with me. So that question bank contains unit 1 questions only. So all these unit 1 questions you have to answer, and I will give all the details how to submit. All the details I will give. Whether you can take your what is that, you can take photograph your assignment and you keep that in your drive itself, your drive itself. Okay, and that drive link you share, so that your assignments will not occupy my drive. Okay, your assignment will be there in your drive fully. So meanwhile you see how to save your assignment in your drive, and for that file what is the shareable link, you have to copy that link and you have to submit only that copy to me. I'll give you a form. In that form you have to submit that link only. Like that I have conducted for your seniors also, second semester VLSI. So all of them have submitted their link, but they have not given rights to open that link, right? So you learn this also properly, how to keep a file in your drive, and how to get a shareable link, and how to give access permissions to me. You have to learn and then only I can visit your assignment 1, right? So all this I'll place in my website. Assignment 1 questions, question bank, and due date, everything I'll mention, and there will be the due date. After due date, we will not receive any responses as usual. Okay, so with this I can say we have completed our unit 1, integrated circuits, differential amplifiers, DC and AC analysis, dual input, balanced output, properties of all the amplifiers, DC coupling, and what is that, cascaded differential amplifier stages, lever translator or level shifter, all that. So with today's class we have completed unit 1, right? So in the next class, tomorrow's class, if possible, I try to recap unit 1, these level shifting circuits if required. Otherwise, if there is no recap required, then tomorrow's class I will start unit 2 for you, right? So in unit 2 also you just see integrated circuits, types, classification, packages, temperature ranges, power supplies, all these we have studied already. So that is also like recap only. So tomorrow we shall start unit 2 if possible, right? So shall I stop here? Just be online.
Yes, ma'am.
Online, let me take your attendance once again, right? Okay, ma, right? So here I'll stop my today's class, and try to follow all the classes, right? And you have to attend another class now. So you can leave this class, otherwise I'll stop